Today we will be learning about the equilibrium constant and the reaction quotient expressions. So this is a topic after Gibbs free energy. So written here, at equilibrium, the concentration of both reactants and products no longer change. The relationship among the concentration of the reactants and products of an equilibrium system is determined by the law of mass action. So, unsa yung pasabot? If you remember, our concentration natay percent by mass, percent by volume, and napod tay we also have parts per million, molarity, like mole per liter, the molality, and the mole or mole per kg, right? Like that. So the concentration here refers to either M or small m. So ana siya na at equilibrium ang concentration for both products and reactants no longer change. Okay? So, I have to mag-ask kung kano sa day siya maka-achieve, when can we achieve chemical equilibrium? So, look at this, natay structure sa to ang chemical equation. We have two arrows here. One is in forward reaction and an arrow facing from right to left. It means that it's going to a reverse reaction. So unsa na to pagkuha sa how do we get the rate of forward reaction? Forward reaction is from left to right. Okay? So how do we get that? We use this formula here. We have R sub 1, meaning ratio 1 in the forward reaction, equals K sub 1 square bracket A to the power of A. A here is the coefficient. If we solve for rate, it will become an exponent. May mo siya exponent, right? So before ka mo solve for R sub 1, make sure that your formula here, that your chemical equation here is in balanced state. And we also have B raised to the power of small b, still in square bracket. Well, the rate of the reverse reaction is denoted by R sub 2. R2 is equal to K2, C to the power of C, B to the power of small b. So this is their rates. So it says that at equilibrium, the rate of forward reaction is equal to the rate of the reverse reaction. So at equilibrium daw, si R1 ug si R2 kay ma-equal. So kung ma-equal sila, meaning we have K sub 1 kani here. Then equal K sub 1 A raised to the power of A, B raised to the power of B is equal to K sub 2 raised to C raised to the power of C, then D raised to the power of D. So to get the constants of K, ratio of the constants, K sub 1 and K sub 2, we have kaning K sub 1 over K sub 2, mo makuha. You can denote this by K sub C, meaning equilibrium, K here is the equilibrium constant. So C here doesn't mean the word constant, but C here is for concentration, meaning either molarity siya or molality. Okay? So this is the final equation. Then here K is the equilibrium constant, like I said before. C in C here indicates that it is in terms of concentration. Why are we using hard brackets instead of parentheses? We show hard brackets are used to indicate that the givens in the problem is in mole per liter. This is molarity. Okay? what if parenthesis akong gamiton, ma'am? Then, you expect that the given is in pressure, is in atmospheric pressure or ATM. So notice the difference. If you have this natay K sub P equal to, if given nato is ano, pressure of C raised to the power of C, pressure of D raised to the power of D over pressure of A raised to the power of A and pressure of B raised to the power of B. Okay? And A, small a, B, C, and D here are the coefficients in the balanced equation. There are two types of equilibrium. So we have homogeneous equilibrium and heterogeneous equilibrium. So let's first start with homogeneous. Okay? Homogeneous is when systems in which all reactants and products are in the same physical state. Heterogeneous equilibrium is when systems in which all reactants and products are in different states. So if I give you a chemical equation, we have H2G gas plus I2 iodine 2HI gas. This is an homogeneous. Why? Because they are all in gaseous state. Heterogeneous is when we have CaCO3 as CO2G. So notice that we have only one gaseous state here. So the rest of the two are in solid form. So this is a heterogeneous equilibrium. Okay? So to illustrate, if I tell you to write the forward reaction of this homogeneous equilibrium, when the given is, kung ang given niya is in mole per liter, you would say R sub 1 is equal to forward direction. We have A, this is K sub 1, and K here is H2 I2. So this is the forward direction, rate of forward direction. If it's in reverse, we have K sub 2, and we only have 1 here. So we have HI squared. So what if the given is in atmospheric pressure? So the rate of forward reaction will become R sub 1, K sub 1, P H2, and P I2. The reverse would become K2 P HI squared. So you can solve this if ang given niya is in ATM. Dayon, masolve po mo siya if ang given niya is in mole per liter. How about this one? What if I tell you to write the reverse, the forward reaction of this heterogeneous equilibrium? Write the R sub 1 if the given is in mole per liter. So, same, we have CaCO3. The reverse reaction, or reverse direction would be K sub 2 CaO. So, of course, imong i-check if balance ba jud ha before mo magigani. And we have CO2. If I tell you to write the reverse direction, if the given is in atmospheric pressure, you would only write R sub 2 equals 2 CO2. Ma'am, ngano CO2 raman ma'am? Asa di ang CaO? Notice that walay atmospheric pressure ang solids and liquids. Only the gas. Ang gas ra ang naay given nga ATM. Dili mo apply ni nga concept, kani nga concept ba? Kaning parenthesis nga concept na siya ipidre. Dili ni siya mo apply sa solids and liquids. This is only applicable for gas. Okay? So, kung moingon ko, write the forward reaction, if the given is in atmospheric pressure, you will say na wala ay forward reaction if ang given niya is ATM because wala ni di makakaingon, this is invalid. There's no such thing as PCaCO3. That's wrong because CaCO3 here is in solids, not in gas. Okay? This is what we call the reaction quotient. So this is denoted by Q. So the reaction quotient is a measure of the relative amounts of products and reactants during a reaction at a particular time. So meaning ani. So si Q daw kay mao ni siya ang imuhang relative amount. Mao na siya ang imuhang equilibrium constant given a particular time. It doesn't necessarily mean na time. Like time na 1 p.m., 2 p.m. It doesn't mean like that. Like, mingon ra siya nga, unsa si Q kung ang reaction kay nahitabo at 100 degrees Celsius, for example. So, this particular time is in terms of temperature. So, I will illustrate it further later sa example. So, it is said that the form of expression for reaction quotient is the same as that for equilibrium constant. Is the same as that for equilibrium constant. The same. So, same og value si K and si Q. Not the same value, but the same formula. The only main difference is that the concentrations of each reactants and products that appear in Q are not necessarily in equilibrium concentrations. So, ang Q di ay kay dili siya because it's only in a particular time. Dili siya like fixed na kana jud dara gid mahitabo ang equilibrium during this Q. But okay, tanaw na nato example later and I will give out an example and an exercise. So this is what it means. So si K, 'di ba? Remember mo si K K sub C man ni siya. And this is the reaction, this is the equation. So si Q, pwede pa siya makuha ani through this. Same sila. But aningon sila. Ang atong isolve per me here is not the K, but actually the Q. The K here will be given in the problem. So if K is less than Q, we will say that the reaction proceeds from left to right. The reaction proceeds from left to right. Example, remember pa man A plus B.
plus dt, right? So if Q na atong gisolve is less than K, then the reaction proceeds from left to right. So this one. In the forward reaction, this should be direction. This is also should be direction. So it means that as product concentration increases, the reactant concentration decreases. Kung magkadako ang concentration nimo dire, imong molarity or molality, imong percent by mass, percent by volume, parts per million, magkagamay ang imuhang concentration sa reactant. So when mahitabo ang equilibrium, it says here that increasing the value of Q until eventually equilibrium is attained. So during forward direction, when Q is less than K, maka-attain siya og equilibrium if you increase the value of K in the forward direction. Okay? What will happen if Q is greater than K? The reaction proceeds from right to left. So this is a reverse direction. So this is mo niyang ginamin, reverse, from right to left. Okay? Ang mahitabo dire, as reactant concentration increases, kung ang imuha ning patasan ang iyahang concentration sa A and B, sa reactant side, ang iyang product magka-decrease. Ang concentration sa iyang product magka-decrease. So, lowering the value of Q, it says here, lowering the value of Q until eventually equilibrium is attained. So, when it is in reverse direction, magkagamay imong Q hantod maka-reach ang equilibrium. Again, if Q is greater than K, dapat magkagamay imong Q in the reverse direction. So, imuha dapat magkataas ang imong concentration sa reactant, magkamubo ang imong concentration sa product. It is the opposite when Q is less than K. Okay? So, what will happen if Q is actually equal to K? So, equilibrium is then attained. Di na kakaingon if forward direction or reverse direction. So, this is the goal, actually. This is what we want. But most cases, most in our examples, kay either the forward direction or in reverse direction. Okay? So, as an example, sample problem 1. In an evacuated 3.0 L flask, naatay 0.35 mole. So, this is in liters. Natay 0.35 mole, nakatay 0.25 mole of Cl2, 0.35 mole of SO2, and 0.30 mole of SO2 Cl2. Okay? So, if you can imagine, if natay flask, unsay iyahang liter? 3.0 liter. So, magsulod ta og mag-add ta, magsulod ta og 0.35 mole nga SO2. Then, magsulod na po ta og 0.25 mole of Cl2. Then, again, magsulod na po ta og 0.30 mole of SO2 Cl2. They are combined and heated, gina-heat siya at what? 100 degrees Celsius. This is the particular point in time. At 100 degrees Celsius, nag-combine ka aning SO2, Cl2 o SO2, Cl2 in a 3-liter flask. The question is, what is the value of Q and in which direction will the reaction proceed in order to establish equilibrium? So, I hope that is clear. Ang gipangutanan niya, unsa ang Q o asa siya na direction, either reverse or forward direction, para maka-achieve siya og equilibrium. Okay? So how do we solve this? Okay, so solution. So we know that we have 0.35 mole and gibutang na to siya in 3.0 L. So this is 0.35 divided by 3.0 is 0.12 what? Mole over liter, or this is molarity or capital M. Then ato na pong gisulod si 0.25 mole. This is SO2. This is Cl2 over 3.0 liter. 0.25 over 0 over 3. This is 0.8 no, 0.08 mole per liter. And then we also have what? SO2 Cl2. So this is 0.30 mole over 3.0 liters, or .1 mole per liter. And of course, before kamo tanaw sa if balanced na siya ha. Look at this, if it's already balanced. This is already balanced with 1 coefficients each. And the given here, K constant, na siya given daan. So this is actually the full equation. Then we solve for K. How do we solve for K? How do we solve for Q again? Q is the same as K, right? C, D, E. A to the power of A, B to the power of B. Or, C na to, we have SO2, D, Cl2, and then we also have only SO2, Cl2. We only have one term for the reactant. So, therefore, this is 0.12 M, capital M, since this is molarity, and this is 0.08 M over what? 0.1 M. So the final answer is 0.096. So, in conclusion, therefore, Q is what? Greater than K. We will say that since it's greater than K, it's greater than K, right? Unsa ang greater than K? Reverse. Right, reverse direction. In order to proceed in order to attain equilibrium, the reaction should proceed in the reverse direction at what? At the rate. So this is the Q here. This is not the concentration. This is the rate. It's actually the quotient, or from what I have told you earlier, since this is product over reactant, this is the rate. In order to attain equilibrium, the reaction should proceed in the reverse direction at a rate of Q equal to 0.096. Okay? So for your activity, this should worth how much? Should worth around, I think, 3 points. Dali na kayo na siya. Predict the direction in which the reaction will take place to attain equilibrium. If the starting partial pressure are 3.0 atm for NO2 and 1.5 atm for N2O4 at 100 degrees Celsius for the following system. So we have a simple, already balanced chemical equation here, and notice that the givens are in atm. So just so I can know that my students are answering this for STEM A, B, and B, C, and D. Please write the problem in a crosswise paper lang, and the answer should be brief here. No complex solving is needed. Okay, so if you're listening to this podcast, if you're listening to this video lesson, use a crosswise sheet of paper. Do not use one whole sheet. Okay, so thank you and have a great night ahead. Goodbye.